Welcome to the world of the electronic racing rodents. During the next few minutes, we would like to introduce you to Micromouse and to show you what mice are, what they can do, and how you could build a mouse for yourselves. Learn a lot and have fun doing it. We also hope that you will begin to see how the technologies you use to build a mouse can lead you into many aspects of engineering, design and manufacture. And we will visit the IEE Micromouse Championships to see how mice compete on the day in the battles for the coveted cheese trophies and cash prizes.
The aim of the competition is to get a little self-controlled robot from the start square, which I always think of as the bottom left-hand corner facing north, to the target, which is the 4 middle squares just there. How the mouse does it is up to him, but the rules say you mustn't knock any walls over, you mustn't climb over them, and no leaving a little trail of breadcrumbs because the birds will pitch them anyway. In Class 3 of the competition, the mouse may be run on an umbilical, or if you like, an umbilical cord to a processor standing by the side of the maze. Seems to be an easier way because you can run a great big processor at the side of the maze, but the umbilical itself causes problems, as a few people will know. The common way of sensing where the walls are is by infrared shining down onto the walls, but some people use micro switches, some people have tried sonics, there have even been mice with semi-complete video systems on board looking at the gap between the white walls and the black maze. The reasons for the colours are twofold. One, it makes it look pretty because it's quite a dramatic picture, this maze, but also the matte black is meant not to reflect infrared, and the top of the walls is supposed to reflect infrared.
Now this is quite a challenge for a robot, and to be able to do all this, a really with-it advanced mouse is going to need a lot of skill. Mice that have been developed to advanced specifications can be very fast. Once the maze is mapped, they can run to the center in seconds, and we have just seen a few examples of these.
This one is designed as a wheelchair. It has 2 wheels here on the side, and with 2 wheels you can either go forward or back, or you can turn in place so that it's very easy to steer and it's not so complicated. There's a processor in the middle, a microprocessor, that's used to coordinate all the motion of the mouse itself. We have sensors. You can see these little black squares here. There are sensors at the 4 corners of the mouse, and there's also ones that look to the front and the back. And so the mouse steers itself as it goes through the maze by sending a beam of light out to the side of the wall and then measuring what comes back. And it can use that to measure what this distance is. And it knows that the maze is 18 centimeters wide, and so it knows that there should be about 9 centimeters on either side, and it calculates that, and then it steers itself according to that. Previous designs that we've had have measured the position of the drive wheel itself, but that's the one which is trying to brake or accelerate, and so if the wheels slip, then you lose track of where you are. By having a separate set of sensors, we can actually see where we are if the wheels start to slip. Some of our mice have little anti-lock braking systems in them so that we can, it's particularly good when you're accelerating. If you're trying to accelerate and the wheel slips, then you can sense that situation and accelerate a little, not so hard. When you're braking, of course, just like in a car, you never really know what to do. You sort of need to stop. That's why you locked your wheels up, and so now you know that you can't stop that quickly. So anti-lock basically keeps you from losing control. It keeps you so you're going straight, but you're probably going to come into the next corner a little fast, so you may lose it at that point, but you might not. The previous one that we made that we raced in Japan last year had 4-wheel drive and 4-wheel steering, and it has 8 motors on it. It's a very complicated mouse. And so as a result of that work, I thought, and some analysis I did last summer, I decided that maybe it would be time to take the improved technology that we've developed over the years and apply it again to the simple wheelchair design. And so this is that effort.
Others, at intermediate and teenage levels, take longer, but they get there, and that is the first objective. Many have problems on the way. Oops. Back to the pits for a quick fix-it. Or perhaps a trip to the back of the envelope. And maybe back to school to prepare for another run next year.
Ready to go? Yep. When you're ready, go. So, A lovely mover. Classical design this. Tricycle mouse, 2 wheels at the back, and the front wheel is just a little caster that stops the front dragging on the ground. And the machine is driven and steered rather like an invalid chair. To go left, you just wind this one forwards, and to go right, you wind that one forwards, and so on. Stepper motors using little pulses of power to step the motor around one at a time. Anyone who doesn't know how stepper motors work, get the book. That's an excellent mouse, and I've seen some mice in my time. Yes.
It's not been easy for us to decide this year because we've had very good mice competing here, excellent times and scores. The category of mice with umbilical. Columbus has the first prize. Would you like to come and collect it? The prize of £100 and a cheese. In the teenage category A, mice with umbilical, Fred, come on, well done.
A must, if you are thinking of building for the main level of the competition, is a copy of the rules and technical information. Also, a number of companies are able to supply suitable components from their standard ranges of product, or, in the case of one company, to offer a customized Micromouse assembly kit. Right, but let's be realistic. There's obviously a lot to know to be able to build a mouse for the main teenage level of the competition. Time is limited, and this amount of knowledge isn't normally a part of curricular learning until at least 16 to 18 years. So, the IEE is introducing a new Micromouse Schools competition for younger students. The circuit is laid out on matte black paper. Navigation is by line following. The circuit is a continuous white path, 50 millimeters wide, which is available from the IEE on a pre-printed sheet 170 by 108 millimeters, or it can be laid using 50 millimeter masking tape. Quick and easy, convenient to store. Distance markers help mice to compute position. 2 levels of competition are available: Standard and Super. The Standard competition circuit is for pre-programmed mice designs. The circuit design is fixed. Each mouse has up to 8 laps in which to record a fastest lap. The shortest lap time wins. The Super circuit is for the more intelligent, decision-making mice. This circuit design is variable and is only revealed at the time of the competition. It is a sudden death competition. Mice run until stopped by the handler or officials. The fastest lap counts. These line-following stages enable you to gradually learn and apply the technologies on your own, or more likely as part of a team, such that the skills for building the 3D mice can be in place by the time you're 16. The school's competition with the line followers will run on the same day as the main 3D competition. It's a great opportunity to learn, achieve, and have fun all at the same time. Micromouse. We could do that.
Thank you for turning me on. I will find the shortest route.
Micromouse. We could do that.
I will have a lot up here. I hope I do not get lost.
Micromouse. We could do that.
This is amazing. It's not supposed to move.
That's in here.
It's been dead for 10 years.